Hi everyone, welcome to Geek Coding Academy. Today we'll see Collection Framework Chapter 6.3, that is Set Interface and its implementation. So in our previous video, we covered what we mean by Collection Framework and what are the core interfaces of the Collection Framework. And also we covered List Interface and its implementation. Today in this video, we'll see what we mean by Set Interface and its implementation. So if you have not watched our previous video, please go to my channel and watch those videos prior to this. So let's see what is set interface and implementation. So before going to set, let you let like can I'll brief you. If you guys does not if you guys do not watch my previous videos, I'll brief you. Like collection framework is nothing but predefined classes available for developer to use. So why we need collection framework is, first of all, programming language is to structure and manage our data, right? Like this collection framework contains some of the predefined classes which is given by Java team, and if you use those, we can easily handle our data. Okay. In collection framework, there are two parent interfaces. One is collection interface, and another one is a map interface. Under this collection interface, we have sub interfaces like list, set, and queue. For these each interfaces, we have a subsidiary child classes which are implementing these interfaces. Similarly, if you go to map, for this map interface, we have a child classes which is implementing these maps. So today we already saw about the list interface and its child classes. Now we'll see what is set interface and its child classes. Okay. So the set interface in Java is a part of collection framework that I already told, and it is used to store unique elements. Okay. In list, as we compare to list, in list duplicates are allowed, but here duplicate values are not allowed. And it extends the collection interface, and it is behaves similar to mathematical set. So in mathematical set, is a is not is unordered, right? So similarly, um, the set interface and its child classes are all unordered, means insertion order will not take into consideration. Suppose if we insert one element and if we insert another element, we can't give a guarantee that other element will be on the second element only. Like insertion order will be not recorded in set. The main purpose of set is to prevent duplicates, because in set duplicates are not allowed, and also insertion order, it does not keep the insertion order. It's unordered. And also it is why it is used is for quick lookups, making them useful in various situations. Like suppose I am creating an application where I need to store the members of a group or club membership, something like that. Like I just want to add a user so that I can use the set interface. Suppose if user already available, it will does not add it again. And also the insertion order, if I don't need in my application, I can go with the set interface. Let's see what are the key characteristic of set. So I already told duplicates are not allowed. Like instead, no two elements should not be the same. That we have to take care. If the element is same, it will skip the other element while adding. And no indexed access. Like unlike list, in list index is the most first thing when we check in list. But in set, index is not we can't able to access the element by index because it's not ordered, it's unordered. So there is no concept of index. Like it will be add whatever convenient places. Okay. But we need to iterate over in order to get the element. We need to search by element itself, and it does not maintain an order. Set generally do not maintain the insertion order, even though like some implementation like linked hash set will provide this feature that I will talk about. Like only one child class will provide insertion order. That too because we are using the linked list concept, but rest all other child classes in set does not provide an insertion order. We'll see the what are the common implementation. Before going to common implementation, like let's see what are the methods available in the parent interface, that is set interface. In set interface, it includes some of the methods which inherited from collection interface also. Along with that, particular to set interface, we have some of the methods. We'll see. First, we have an add. As you guys can see, like in our previous video also, we talk about this method. It is coming from the collection interface directly. It will be added to both list and also set. Means add means we are adding an element to this collection. Okay, if that is not present in case of set. Okay, in case of list, it will be add because whether it doesn't care about that element already available or not, because duplicates are completely allowed in list, but in set duplicates are not allowed. Remove of object of, like in remove is a method which accepts a element. What it will do is it will iterate over the entire list, entire set, and it if the element present, it will remove that element. The contains, again the contains method, which is also look into the entire set, and it will return true if that element present in that set. The size is which will return the number of elements in the set. Iterator, it will return an iterator over the elements in a set. That means like it is just like a for loop. We need to iterate over in each element individually. We go with an iterator. So how, what is iterator and what are other methods to iterate over these collection framework elements? I'll see in the next chapter. We have a dedicated chapter for this. We'll see there. Clear means remove all elements from the set. We use this method called clear. Let's see what are the common implementation of set interface. There are a lot of child classes of set, but I picked here some of the most used common implementation of this set interface. Hash set, linked hash set, tree set, and enum set. Okay. So let's see what I mean by an hash set. So hash set is one of the most widely used child class or implementation of set interface. It uses the concept of hash table for storing an element. It is unordered. That means insertion order is not preserved. Okay, that is the same feature of set. It was inherited here because it's a child class of set interface. The feature is it does not allow duplicates. Okay, and allows only one null element. The hash set will allow only one null element, and it provide a constant time O of one. The constant time for basic operation like add, remove, contains. Assume the hash function is properly distributed. What is hash function? We'll talk about that is in the advanced concept, like what is hash table and how to return a hash function. We'll talk. Java will provide a basic hash functionality. If you want, suppose if we are doing any complex application, suppose we have any complex application like Google, Amazon, and we want to implement our data set using this hash set, there was possible that this hash table will find out some hashing concept. These hashing keys may collide sometimes. That is what we call as an hash collision. In order to avoid that, these hashing functions we have to define. We can also define them manually. There are some advanced concepts. So later, after this collection framework, I will cover all this. And it does not maintain any insertion order that we saw. So then, what is the like when we need to use this? Let's see. So when we don't want to care about the order of element, like whatever time it has added, I don't want to care. Just I want to store the elements, but I don't want a duplicate. I want fast insertion, deletion, and lookups operations. Then I definitely go with an hash set. Okay. So this is a syntax where I just created a class which is a public class, main class, and in main class, like we have in a main method. So this is a syntax. I'm using a new operator to create an object for this hash set class. So it will capture by with this reference variable set, which is of type set, its parent interface. Of and the storing data to this collection is string that I have mentioned here. Using an add method, I'm just adding the elements to it or data to it. Set that add apple, set that add banana, set that add apple. See here, apple and banana already been added. Still, I'm just adding in an apple again. This is a duplicate. So what this hash set will do is it will not add this. It will not be added. Okay. Once I print this set, I can only see banana and apple. Okay. So let's see in another type of child class or another implementation of set interface is linked hash set. I already told in hash set order is not preserved. The insertion order is not preserved. To solve this linked hash set concept has been introduced. Like linked hash set class has been written. Here it is also a subclass of hash set, and also it maintains a linked list of entries. Okay. In linked list, we saw all list and its child classes preserve an order. So it maintains using a linked list of entries in a set. That means it maintains the insertion order of elements. Okay. So feature is it inherits all the properties of an asset. It's similar to an asset, such as no duplicates are allowed and only one single null element will be allowed. And also it maintain an insertion order. In addition to an asset, linked asset will maintain an insertion order. That is, elements are written in order in which they are inserted. That is what called insertion order. Performance is slightly slower compared to an asset because need to maintain the linked list type of setting up of data, maintain the linked list, but it still provides constant time for a basic operations. Okay, let's see the basic syntax and when to use. So when we have to use a linked asset is when we want to maintain an insertion order while still having a fast performance of insertion, deletion, and lookups. Okay, and also no duplicate. We don't want duplicate values in our collection. Definitely, we go with a linked asset. Here, I just created a class and having a main method. Inside that, I'm using this linked asset object I created and I pass to this reference variable set, which is of type set. Okay, it's parent interface, and I'm storing type of value is string value. Using an add method, I'm just adding these values. Apple, banana, cherry, apple. Again, I want to adding an apple, which is already been added in the list, sorry, in the set. So it will not be added because this is a duplicate. When I print, it will be print in the order apple, banana, and cherry because linked asset will preserve an insertion order. Okay. Let's see another type, tree set. Okay. So what is the difference between tree set, asset, and linked asset? In asset, insertion order is not there, but in linked asset, it's similar to asset, but insertion order will be preserved. In tree set, what it is in tree set, it will be sorted. Okay. So tree set implements a sorted set interface, which is a child interface of the set interface. There will be sorted set interface. Under this tree set class will come. This is a child class of sorted set, and sorted set is a child interface of set interface, which means it keeps element in a sorted order. Okay. By default, it's like it sort with an ascending order. If you want our own logic, we can use like if you pass our own comparator, it will compare and sort based on that. Like internally, it uses a red black tree to store elements. What is the red black tree? We'll see when we go with the DSA concept, data structure algorithm. I'll start after these chapters. So we'll see what is a red black tree concept. Like it uses that concept to store elements. Feature is it ensures that the elements are stored in an ascending order and it does not allow duplicates. It does not allow not even one null elements. Provide log and time complexity. Okay. It provide a log and time complexity for basic operation like add, remove, or lookups contains. So this is the syntax. So when we need to use this tree set, when you need a set or when we want to and like manage our data in such a way that the data stored in a collection in the format of natural order or like ascending order, and there is should not be any duplicates. Okay, and it should be stored in an ascending order. So or custom order defined in a comparator. Suppose if you want any other order, another type, like suppose descending order or order by some value, we can give using a comparator. We'll see what you mean by comparator in our future videos. Till now, like if you use a tree set, it will be sorted by default in a ascending order. So I created a class here, tree set example. I have a main method and I created a object of tree set here where its reference is carried to this set reference variable, which is of type set. And I'm storing a value here is string. So I'm referring here type string. So using an add method, I'm just adding these string values, banana, apple, and cherry. When I print this, I get this apple, banana, and cherry. It's in a sorted order because it's sorted by ascending order of alphabets A, B, C. Okay. So let's see another type child class is enum set. So what is enum set? So enum set is a specialized set implementation for use with enum types. Enum types are some constant we defined already. Some values we defined already in the code. So whenever we are adding data to this type of collection, only it will consider those type of values which we already defined. Like I'll show you an example so that you will understand much better. So with an enum, all elements in an enum set must come from a single enum type. Okay, that enum type we have to define. Okay, what is a feature? It's extremely efficient for storing a enum constant that I already told, and it uses a bit vector to represent these elements. Like it does not allow null elements, and the enum by default enum set is not synchronized, means not thread safe. Like I'll talk about what is in thread concept, what is synchronized and what is thread safe. Like, but we can use some of the we have some utility classes and utility methods. Using that, we can make it as in a synchronized by using collection dot synchronize set for thread safety. We can make it using the utility classes. The utility classes at the last end of this chapter, I'll talk about the utility classes available in this collection framework. Okay, so let's see when to use this. So when we need when to use this enum type like enum set, when we need to use these, when we need both performance and also we need to see the memory should be efficiently managed. So in our application where memory and both performance should be need to check up, need to be optimized, then we go with this enum set. But in enum set, we have to define some values in a enum constant. So here, this is my syntax. Like I just created one enum of day. This is how we need to define an enum constant. Day, like all, I'm just storing all the days, like Monday, Tuesday to up to Sunday, which is variable name is day, which is of type enum. In my main class, I have a main method. So I'm just creating a enum set dot off day dot Saturday and day dot Sunday. Both Saturday and Sunday, I'm just putting in my weekend object. So which is of type enum set of day. When I print this weekend, it will print this Saturday and Sunday. Okay. So this will be used when I need to see both performance and memory efficiency, which will be critical in our application. Then we go with this enum set. So let's see the comparison of all once again, all set implementations. For ordering, as set, it's unordered, means insertion order is not preserved, but linked as set, insertion order is preserved. Tree set, it's sorted order, by default is ascending order. If you want any, we can give it with the help of comparator. Enum set, it's enum declaration, like whatever value present in enum declaration, it will be added. Other values, we can't able to add it. But duplicates, as set will not allow duplicate, linked as set also, tree set also, enum set also, because set won't allow duplicates. And null elements, as set and linked as set allowed only one element, but this tree set and enum set will not allow any null elements. Time complexity, as set and linked as set will be O of 1 for basic operations, but tree set is O of log n, enum set is O of 1 and it's very fast. Okay, implementation, like these classes returned on top of what data structure logic we'll see. For as set is as table, means it will use an as table to store the data. Linked as set will use as table because it's a subclass of as set, and also the linked list concept to for the insertion order. Okay, to preserve the insertion order, it will use both as table and linked as set. Sorry, linked list. Tree set, it will use the concept red black tree. We'll see what is that. Enum set, it's a bit vector way of representing data. Use cases in generally we use as set. If set means you may think of it as set. Linked as set when we go is we need to preserve a order. Okay. Tree set when we go to sort the data, what we are storing in the collection set. For enum set, enum collection. Only I'm boundaried with my enum collection, I'll go with an enum set. So let's see in the use cases. So first is as set. It is ideal when fast lookups like insertion, deletion, okay, are not like are needed. Means fast lookups like and insertion, deletion are needed. I don't want to concern about order of data. We can use this. For linked as set, used when the order of insertion need to be preserved while still maintaining a good performance. Like what are the features available in as set needed, but also along with that, we need an insertion order. I'll go with a linked as set. Tree set is best suited for scenarios where elements need to be sorted at the time of insertion, such as maintaining a list of sorted items like a dates, names, or scores directly used in a tree set. Enum set is like used when working with enums, and it's highly efficient and type safe for enum collection. Okay. So let's see the conclusion. The set interface and an implementation of a powerful way to manage collection of unique elements in Java. Why unique means duplicates are not allowed in set. So each implementation, means each subclasses or child classes of the set interface has its specific strengths. So we need to understand the difference between between the child classes, and we need to choose the right one for our code. Okay. For as set is a common implementation we have to use if it's in a general cases, means where insertion order is not preserved and duplicates are not allowed. If you go within a linked asset where duplication is not allowed and insertion order is also preserved, and when we see about these tree set where we need a sorted order data, like default will be in ascending order. If you want, we can write our own custom, and enum set if you want to use with an enum type of data. Okay, that's all about theory, guys. Let's go to code so that you'll understand much better. Okay, so I created a class called set collection demo. So here for the very first I created an enum which is of like name is day, which is of type enum. I created both Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, all names of week names, sorry, day names. And I created a main class here, set collection demo, which is of type public because main class should be public. From there, the control flow will enter. Inside this public class, there will be should be having at least one main method, which should be public static of void. So control enters through here. Here, first I'll go with an asset example. So I created an asset object and passed into an set reference because it's a child class of set interface. So I'm just using an add method to add apple, banana, cherry, and apple again. Because it's duplicate, it won't be added. When I print it, only apple, banana, cherry will be available. What about linked asset? Linked asset, the order is preserved. Here also same. I created an object of linked asset and added the value of type string. Apple, banana, cherry, apple. This apple, last apple will not be added because duplicates are not allowed, and also it maintain an insertion order. Okay. Tree set. Tree set where it will be sorted in ascending order by default and duplicates are not allowed. Banana, apple, and cherry I've added. When I print this, print the value added in this collection, it will be automatically sorted in ascending order. Okay. So enum set ordered off. I'm just adding in a Saturday and Sunday only to this enum set, which I created using an enum set off. So when I print this enum set, I'm just printing in a Saturday and Sunday. Later, I add one more day as in a Friday. When I print, it will including a Friday. So let's run the program and we'll see. So as you can see, guys, apple, cherry, and banana. One more apple is not added because duplicates not allowed in asset. Linked asset, apple, banana, and cherry. Like here also duplicates not allowed, but insertion order is preserved. Tree set, apple, banana, and cherry. See, it is automatically sorted because tree set implements sorted set, which is a child interface of set. So enum set, initially we can we have a Friday, a Saturday, and Sunday. Later I added including Friday, so it will be added. To include, you just use an add method. Okay. So guys, this is all about set interface and its implementations. In our next video, we'll talk about another child interface of this collection framework, that is queue and dequeue and its implementations. So till then, keep watching, keep learning. Thank you. Bye.